Hi, everybody. Welcome to TGCS. My name is Tim Gallagher, and today we are going to be discussing AP Computer Science A topic 4.13, implementing 2D array algorithms. And in this third video, we'll develop code for standard and original algorithms that involve 2D arrays and determine the result of these algorithms. Specifically, we're going to focus on these three algorithms. First, determine the presence or absence of duplicate elements in the 2D array or a designated row, column, or other subsection. Next, shift or rotate elements in a row left or right. And finally, reverse the order of the elements of a row. Again, before we get started on implementing, we're going to talk about the algorithms. And when doing the algorithms, we want to determine things like, do we need a row major order traversal or a column major order traversal? What is our goal? What type of results do we want? Are we modifying the array perhaps? What types of values are in the array? Are they objects or primitive types? And do we always need to traverse the entire 2D array, or are we looking at a specific row or column? And under what conditions could we halt our algorithm before traversing everything? So let's start with implementing this method. We want to determine if there are any duplicate values within a given column. Now, this method returns true if there are, false otherwise. But let's discuss the algorithm first. What are the steps that we'll take to find the existence of any duplicates? Well, first we know we're going to need to traverse a given column. So we're going to increment through each row within a column. And to look for duplicates, it would be easiest to check all of the elements that are contained in the rows after the current element. So how can we do that? Well, we'll do it by traversing the column, starting one after the current element that we're in within the column. So we're going to have a loop inside of a loop. We're going to have nested loops. If we find that any of the values are equal to each other, we immediately return true because we found a duplicate. If we traverse all the way through an entire column without finding any duplicates, then we're going to return false. So pause here if you'd like to try implementing this algorithm yourself. Okay, let's take these steps and let's put them into our comments and write our code. So here's our comments. We'll start by having a single loop to traverse the rows of a given column. As we extract each element into an integer, we'll call it current. Now we need to traverse the same column, but starting at the next row. So let's have another loop, but this one starts one after the current value of r. Notice we have d initialized to r plus 1. This allows us to have an index for all subsequent rows within the same column. And again, we'll continue our loop all the way to the last row using values.length again. So let's check to see if our current value is ever equal to anyone after it, values d column, as we loop through all of the rows below our current row r. If we ever find a match, then we can immediately return true because it only takes one pair of duplicate values to indicate that there are duplicate values in this column. Then after the loops are completed, we'll return false if we're still here because that means we never found any duplicate values. And that's our algorithm for determining whether or not there are any duplicate values in a particular column of a 2D array. All right, let's try something else. How about this? Within this method, we want to shift all the values within a particular row of a 2D array one position to the left. And while doing so, we also want to take the original leftmost value or the first value in that row and transfer it to the end or the rightmost position of the row. Again, let's discuss our algorithm first. So we're going to traverse a row of the array. So we'll need to increment through each column. As we traverse each element of the row, we want to assign the value that is one column after our current location to the current column. This is what will shift each element one position to the left. Now, we want to put the original first element into our last column. Oh, we didn't save it. Let's go back to the top of our algorithm here, and let's temporarily save the first element in the first column because we know we're going to need it at the end of our algorithm. And that's it. So pause here and give this code a shot if you'd like. and we'll code it together in just a moment. All right, let's turn these statements into comments and write the code for this algorithm. So here we go, our algorithm in comments. First, let's store the element from the first column in our row to a temporary variable. We'll call it temp. Next, we'll traverse the columns of our row using a for loop. Notice that our Boolean condition is less than length minus 1 because we know we want to prevent going out of bounds like we saw in the last video when accessing consecutive elements. Our assignment statement takes the value that is one column to the right of our current value, C plus 1, and assigns it to the current column that we are visiting. Using C plus 1 is the reason why we had to include a minus 1 in our loop's Boolean expression. And then finally, we put our original first element that we had stored in temp into the last column of the row that we've been shifting. And that does it. This will shift all the elements one position to the left and put the original first element in the last column. Okay, for our last algorithm, we want to reverse the elements of a row. So let's look at how we could do that. Let's consider this row of integers that we want to reverse the order of. First, we'll swap the value at index 0 with the value at the end, which is really the row length minus 1. So now 12 and 22 are switched. Next, we'll swap the values at index 1 and index row length minus 2. So now 42 and 8 have switched. Then we'll swap the value at index 2 with the value at index row length minus 3. So 38 and 17 have switched. And with 92 remaining where it is, that's it. Our row has been reversed. So that's our algorithm. And I want to point out a couple of things. First, notice that the pattern for the indices of the values that were swapped. Index 0 swapped with index length minus 1. 1 swapped with length minus 2, and index 2 swapped with index length minus 3. Index C always swapped with index length minus C plus 1. So we can use that pattern to swap pairs of elements as we traverse through the row. Also, notice that we only had to loop halfway through the row to swap all of our elements. We swap each element in the first half with a corresponding value in the second half. This means that our iteration will only need to go to the length of the row divided by 2. All right, pause here if you want to have a go at our last algorithm. All right, ready to look at the code? Let's put down our comments and complete the code. Now, there's not a lot of comments here because our algorithm is short, but it is complex. So let's start by using a for loop to traverse through the columns of a given row. Notice that we're only looping through half of the row by using the length divided by 2 in our Boolean condition. Note that this works regardless if there are an even number of columns or an odd number of columns in the row. Next, let's swap the two elements within our loop. First, we'll need to create a temporary integer to hold the original value in column C, of course, all within the same row. Next, we'll assign the value from column length minus C plus 1 to the position row and column C. And then to complete our swap, we'll assign our temp variable to the column length minus C plus 1. And then we continue our loop until we've traversed half of our row and swapped all of the corresponding elements. And that's it. Our algorithm's complete. We've reversed an entire row of our 2D array. How'd you do? All right. So today we developed code for standard and original algorithms that involve 2D arrays, and we determined the results of these algorithms. Specifically, we determined the presence of duplicate elements in a column of a 2D array. We shifted the elements in a row to the left, and we also reversed the elements in the row itself. So that's it for 2D array algorithms. Thanks so much for joining us here today. Don't forget to hit that like button, subscribe to this channel, and we'll see you next time. Take care.